In this example, we're being asked to compute the value of the output voltage V0 given that the input voltage V source happened to be 0.5 volts in here. Okay, so we take a look quickly. We have a couple of amplifiers. I'll just call them amplifier 1 and amplifier 2, just so that when I speak about them, you'll figure out, or you can actually follow me. So, and taking a quick look at it, neither of them is just a traditional configuration that we know about, and the reason why is because we have a feedback loop that is feeding to the A1 in here, and we have another feedback loop that is feeding in here. So what we need to do is we need to use just general analysis technique, and I'll just highlight what my assumptions are. So because I'm dealing with ideal amplifiers, so that means the IN here is 0, the IP here is also 0. Also this IN, and I can call them, for example, 1 here, 1 in here. This will be 2, that will be 0, and this here IP2 is also 0. Alright, so now what do we know in terms of voltages? Well, I believe we don't know this voltage specifically. We just know that there's no current going that way, so these two are technically in series. But anyway, we don't know the voltage in here, so what I will do is I'll call this, for example, point 1, and I'll assume that the voltage across it, or at that point, not across it, is V1. This is the voltage between this point and ground. Alright, and since we're dealing with ideal amplifiers, that means this is also V1, because this voltage in here and this voltage in here, as if we have a virtual short. So this is also V1. Okay, so we take a look in here. This is the output of the first amplifier, and I don't think we know it. We don't, so I will just basically call this V2. Alright, and I'll highlight the ones that we don't know so that we can track them later. So for example, here's one. Let me just do that. Alright, we'll highlight this here, and we'll highlight this one here. Okay, what else is left? Well, do we know this voltage? We do. This is 0 in here. That means this is also 0 volts. So there's no need for me to actually figure out what that voltage is, but we don't know what V0 is, so we'll have to actually just figure out this V0 in here. Okay, so we have 3 things that we don't know, which is V1, V2, and V0. So we have to come up with 3 different equations to solve this particular example with this particular circuit. So let's start with a V1 in here. Let's write a nodal equation at this particular node, and that will give me V1 divided by R3, which is 3 kilo ohm, plus V1 minus V0, the thing I'm looking for, divided by R4, which is 6 kilo ohms, and that basically is equal to 0. Okay, so we'll clean the equation a little bit so that we have a simpler equation, and that should result in, okay, multiply, for example, I multiply both sides by 6, that will be 2V1 plus V1 minus V0 equals 0. That means we have 3V1 minus V0 equals 0. So that's the first equation. Alright, now let's write another equation at V2. So I'll zoom out a little bit so that we can see it. Well, simply we can say, well, V2, I don't think we can write an equation at V2, so we have to do something else about it. We can't write an equation in here, and the reason why is I don't know the current leaving, so it's usually not a good idea to write an equation here, but I need it, and I know that it's connected, or we could write an equation in here, and that will give me V2. It will incorporate V2, so let me just write this one here. So let me just do that. So we wrote KVL first, we wrote a nodal equation in here. Now what we're doing is we're writing a nodal equation in here. Okay, and that will give me V1 minus Vs, which is 0.5, divided by the R1, which is 1 kilo ohm, plus V1 minus V2, the thing I'm looking for, divided by R2, which is 2 kilo ohm, equals 0. Okay, so we do a little bit, and we multiply both sides by 2, for example, and that will give me 2V1 minus 1 plus V1 minus V2 equals 0. So a little bit of cleaning, and that will give me 3V1 minus V2 equals 1, and that's the second equation that incorporates V1 and V2. Alright, so I need a third equation, and again, it's not a good idea to write it in here, so what we need to do is probably, in order for me to get this node, I have to either write it in here, which I already did, or maybe here. Okay, so I'll write an equation right here, nodal analysis equation right at the inverting input of A2. Okay, and that will give me 0 minus V2, which is also convenient because this point will also incorporate V2 that I'm looking for, divided by the 2 kilo ohm, plus V2, which is 0, not V2, V0 minus V0 divided by the 6 kilo ohms, and that equals 0. Alright, so we'll do a little bit of algebra here. We'll multiply both sides by 6, so that will give me negative 3 V2 negative V naught equals 0, and that will be the third equation in here. So we solve these three equations that we have, and we should be able to get what V naught is. So let me just do that. So I went ahead and I just summarized these equations, and I wrote them in terms of V1, V2, V3. If V2 doesn't appear, for example, I gave it the scalar 0, and all I have to do right now is just solve the three equations with three unknowns to figure out the values of V1, V2, and V naught, and that should result in V1 will be 0.25 volts, V2 will be negative 0.25 volts, and V naught, the one I'm looking for, is just simply 0.75 volts, and that's basically it. So we have everything we need, and that's basically V naught. Now, of course, as an exercise, I would want you to basically figure out what the I naught is in here. For example, what's the output? And it's simply, all you have to do is just write KCL equation in here. By KCL, you need to figure out the current going from here to here. I know this voltage, I know this voltage. I should be able to figure out what the current flowing through this 6 kilo ohm resistor is. Similarly, I know this voltage and I know this voltage, this is V1, and I know this resistor. I should be able to figure out what the current flowing through this here, and you just write KCL equation to figure out what I naught is.